Hello everyone, today we'll be learning chapter 8 of class 9, motion. First of all, what exactly is motion? Change in position with respect to time is motion. So, if an object is at position A at a certain point of time, and then it moves to position B, then it's called motion. And if it doesn't move anywhere, then it is called rest. But an object may be in motion for one person, but maybe in rest for another person. For example, suppose a person X is traveling in a train, whereas a person Y is standing outside and looking at the train. Now, for person X, the train is actually in rest because he can't see the train moving from inside it. Whereas for person Y, the train is actually moving. Now, how do we explain this? So, whenever we are considering position, we should generally describe it with respect to a reference point. Only then it will make sense. Now, if we take Y as the reference point, then the train is actually moving. But if we take X as a reference point, then the train is not moving. Okay. Now, let's look at what else we'll be learning in this chapter. We'll be learning about distance, displacement, speed, velocity, time, a few graphs which connect these parameters, and also the equations of motions. We'll be mainly focusing on motion in a straight line and motion in a circular path. Now let's start off with motion in a straight line. It's very important to get the concept of distance and displacement. First, what is distance? The total path length covered by an object is called distance. To understand this, let's take a simple number line. Suppose this point is taken as origin, that means 0 distance. This is 10 meters. This is 20 meters and this is 30 meters. Now, if an object starts at the origin and it travels till this point, let's say A, then the distance traveled by it is 30 meters. Now, from A, if it goes to B, which is here, then the first 30 meters plus the 10 meters traveled just now, it will be 40 meters. So the total distance traveled will be 40 meters. And again, if it wants to go back to A, then another 10 meters will get added to it and the total distance will be 50 meters. So how much ever distance is traveled, that itself is the distance. You should consider it totally. Now, let's look at what exactly is displacement. Displacement, it doesn't matter on where and all the object went or what is the path or anything like that. It just depends on the initial point and the final point. Suppose this is A and this is B, and the object travels from A to B in this path. Now the distance traveled is this distance plus this distance plus this distance. But the displacement will always be the distance between the final point and the initial point, that is nothing but only this much. So, as you can see, displacement is nothing but the distance between the final point and the initial point. And one more important thing is displacement involves direction. When we are talking about distance, there is no direction, but displacement, we consider direction. So displacement can even be negative. If we consider an object goes from O to this place and then it comes back to here, then this side, the displacement can be considered as negative. One more thing to be taken into consideration is displacement is always less than or equal to distance. Because distance can be anything. You can go either like this or like this or however you want, but displacement is always the shortest distance between 2 points. So in case the distance itself is the shortest distance, then distance and displacement both are same. Otherwise, distance is always greater than displacement. Now let's look at uniform motion and non-uniform motion. In uniform motion, equal distance is covered in equal intervals of time, whereas in non-uniform motion, unequal distance is covered in equal intervals of time. For example, if in the first 1 second, the distance covered is 1 meter, and then when the time is 2 seconds, the distance covered is 2 meters, and in 3 seconds, the distance is 3 meters, then it's uniform motion, because every 1 second, 1 meter distance is being covered. But if it is something else, like if this is 4 meters and this is 5 meters, then it is not uniform motion. Now, we are always talking about distance being traveled in a certain amount of time, but how do we actually measure it? It is measured using speed. So speed is nothing but the measure of distance traveled by the total time taken. Average speed is nothing but the total distance traveled by total time taken. So the simple formula is V equals S by T, where S is the distance, T is the time, and V is speed. Now, using the above formula, we can solve example 8.1. So the object travels 16 meters in 4 seconds and then another 16 meters in 2 seconds. You need not consider how many seconds and all, just take the total distance traveled. So total distance traveled is 16 meters plus another 16 meters. So it's totally 32 meters. And then total time taken, which is 4 seconds plus 2 seconds, that is 6 seconds. Now you can calculate the average speed using the above formula. You need to write the formula when you're writing it in exam. I'm just gonna put the values directly. So average speed is total distance by total time, which is nothing but 5.33 meters per second. In science, it's always important to write the units. So for speed, the SI unit is meter per second, but there are other units such as kilometers per hour. So you should be really careful when using the data given from the question that it is in the units that we want, and you should not mess them up. Now let's have a look at velocity. Velocity is nothing but speed, but with direction. So instead of using distance over here, we use displacement. That's the only difference. So even the direction of motion is involved, but the SI unit stays the same, that is meter per second. And there's the formula for average velocity. That's the case if the velocity of the object is changing at a uniform rate, you can use this formula. Just remember it. Now we have another parameter named acceleration. What if the velocity is changing with time? Suppose at one time it is 3 meters per second and later on it becomes 6 meters per second. This happens due to acceleration. So acceleration is nothing but the change in velocity per unit time. So it's given by the formula V final minus U initial by T. Now let's have a look at example 8.2. The odometer of a car reads 2000 kilometers at the start of the trip and 2400 kilometers at the end of the trip. If the trip took 8 hours, calculate the average speed of the car in kilometers per hour and meter per second. Okay, odometer is the meter which reads the distance traveled by the car. So let us see. The initial odometer reading was 2000 kilometers and the final odometer reading was 2400 kilometers. So the distance traveled is final reading minus the initial reading. That is 2400 minus 2000. That is nothing but 400 kilometers, which can also be written as 4 lakh meters. Now the total time taken by the trip is 8 hours, which is nothing but 8 into 60 seconds, which is 28,800 seconds. Now to calculate the average speed, as discussed per the above formula, it is just total distance traveled by total time taken. So there's a small trick here. They have asked it in kilometers per hour and meters per second. Let's first calculate it in kilometers per hour. So in kilometers, it's 400 kilometers by 8 hours. So it's just 50 kilometers per hour. Okay. Now let's do the same thing with meters per second. It's nothing but 4 lakh meters by 28,800 seconds. 13.9 meters per second. So as I said, it's really important to know the units which you're using and which are asked in the answer. A small trick I'd like to say: when the speed is given in kilometers per hour and you want the answer in meters per second, all you have to do is multiply 5 by 18. So just by multiplying 5 by 18 to the kilometers per hour, you can get it in meters per second. Okay, let's move to the next question. Usha moves in a 90-meter long pool. She covers 180 meters in 1 minute by swimming from one end to the another and back along the same straight path. Find the average speed and average velocity of Usha. So here's where we'll use the concept of distance and displacement. It's important to be very thorough in that concept. So let's consider this as the pool. It's 90 meters long. Usha goes from this point to this point and then she comes back. So let us see. Distance traveled is the distance traveled. It's the total distance. There's no excuse in that. So first, when she goes all the way to here, she's covering 90 meters. And then while coming back, she's covering another 90 meters. So the distance traveled is 180 meters. Whereas when we look at the displacement, we should consider only the initial and the final positions. In the beginning, she was over here and she went somewhere and came back, but at the end, she's at the same place. So the distance between the first position and the second position is 0 because there's no displacement here. So displacement is actually 0 meters. Now let's look at this. All we have to do is write distance traveled equals 180 meters and the displacement is 0 meters. Now let's calculate the average speed. It's the total distance traveled by total time. As they have given it, it's 1 minute. Normally we don't take it in minutes. So let's say 60 seconds. So this can be written as 3 meters per second. And the average velocity, as the total displacement itself is 0, average velocity will be 0 by 1 minute. That is 60 seconds, which is nothing but 0 meters per second. Now a few more things about acceleration. Acceleration is taken to be positive if in the direction of velocity and negative if it is in the opposite to the direction of velocity. Suppose a body is moving in this direction, and if I give acceleration in the same direction so that its velocity increases, then it's taken as positive. Whereas if the object is moving this side and I'm trying to push it this side, then the acceleration is negative because its speed will decrease. Whereas here the speed will increase. Now one more thing here is uniform acceleration. If the speed of the object increases or decreases by equal amounts and equal intervals of time, then the acceleration of the object is said to be uniform. For example, freely falling body, its acceleration is the same. It is not changing with time. So every 1 second, only a certain amount of increase is there in the velocity. Now let's look at example 8.4. Starting from a stationary position, Rahul paddles his bicycle to attain a velocity of 6 meters per second in 30 seconds. So he starts traveling from zero velocity and then he attains a velocity of 6 meters per second in 30 seconds. Then he applies his brakes such a way that the velocity of the bicycle comes down to 4 meters per second in the next 5 seconds. So from 6 meters per second, his velocity goes down to 4 meters per second in the next 5 seconds. Calculate the acceleration of the bicycle in both the cases. So there are two different cases over here. Don't get confused. Just look at them separately and it's very easy. The first case, the initial velocity, normally we denote it as u, can be 0 meters per second because it was at rest. Now the final velocity is 6 meters per second and the time taken is 30 seconds. So as we saw in the above formula, acceleration is nothing but v minus u by t. So just put it in the formula and you get the answer. 6 minus 0 by 30, that is 6 by 30. 0.2 meters per second square. So you should pay attention to the units. Acceleration, the units are meters per second square. Now let's look at the second case we have over here. Now the initial velocity is 6 meters per second, as that's where it starts, and then the final velocity is 4 meters per second and the time taken is 5 seconds. Do not mess it up with the before case because it's totally separate from that case. Only the 6 meters per second are same. So let's calculate the acceleration again. It's 4 minus 6 by 5, which is minus 2 by 5, which is minus 0.4 meters per second square. As we see, acceleration can be negative, just like velocity and displacement. So this is the answer. Graphs are really important in this chapter because they can give the relation between any two parameters. Now let's have a look at the different types of graphs we have in this chapter. The first one is distance and time graph. So normally we always take the time parameter on the x-axis, that is over here. Always remember it's on the x-axis. So the other thing goes on the y-axis, that is distance. Now you have to remember some basic graphs so that they can help you out. Now in the distance time graph, if there's a straight line passing through the origin like this, then it's said to be uniform motion, or the object is said to be in uniform speed or velocity if you consider displacement. From this graph, we can also get to know the velocity of the object. That is very easy. All you got to do is consider 2 points on the distance axis and the time axis. first you should consider it on the distance, any one. So consider this as S2 and S1. You have to draw a line perpendicular to the y-axis which meets the line of the motion, and then you have to just drop a perpendicular to the x-axis, and wherever it meets, that you consider it as T2. Similarly, you do it for S1 and you get T1. So to find the velocity from this graph, all you got to do is V equals S2 minus S1 by T2 minus T1. In this way, you can find the velocity. So this was the graph for uniform speed. Now for non-uniform speed, the graph can be anything. For example, it could be just like this, or in any other fashion, it doesn't matter. The next type of graphs we have is velocity time graph. The first case is again uniform motion, just like we saw in the above graph, where the velocity is actually constant. So when you draw a velocity time graph, again t on the x-axis and v on the y-axis, you'll get a straight line here, unlike the line through the origin in the top one. So yeah, the velocity at a certain point of time and another point of time is actually equal. So that's how you get this graph. So one more thing you need to know about this kind of graph is that the area covered between 2 points under this line is the distance. Is the distance traveled during that time. The next case is uniformly accelerated motion. As we talked about it, in equal amounts of time, the velocity changes by equal amount. So it's going to be a straight line passing through the origin, like this. This is t and this is v. Here also you can find the distance traveled between 2 points. Only thing, you have to divide this area so that you can find it easily. You can find the area of this triangle and then the area of this rectangle so that you can get the distance. The other case is non-uniformly accelerated motion, where the graph can be anything. First it might be accelerated like this and then decelerated like this, or it may be like this. It can be anything.